Welcome guys, this is our first set of official notes and getting started with new material in the class. So you should have already watched the 2 pages about sort of how do you take notes and how are you going to save notes. On the previous day you should have watched how to complete Edpuzzles because that's what this is in. So it's really important that you pay really close attention to the video, what we talk about, that you always go back and rewatch an Edpuzzle video so that you can get the correct answers when it's time, because those become grades. So you should also have uploaded the document here that is going to be your notes that you are going to be recording this information on. This is what the top of it says. I know a little bit may be cut off on the left on my screen right now, but the relationship between magnetism and electricity is our first standard. There are 2 parts to this, so today is going to be, when I say 2 parts, there are multiple pages to these notes, but this is the first part that we're going to really look at with the basic properties of magnets, and then the rest of part 1 will be done on another day, but it is looking at what an electromagnet is, and we'll talk about that here in a little bit. So let's get back to this question of the day that you see up here on the screen. When we do these in the classroom, I have you keep up with them on a piece of notebook paper, and you can do the same thing if you want to, just so that you have access to it and have an answer down on your notes. That should be something that you probably do want to try to keep up with. But right now, what you'll do, instead of answering if you don't want to on a piece of paper, you will have to answer in the Edpuzzle. When you answer these questions, I ask that you give me your best answer, and the best answer is never an I don't know. Okay, I don't accept those types of answers. You may not know, and I understand that. There are many things that I get asked sometimes, and I don't know, but I'm going to come up with the best answer that I possibly can. Based on the knowledge that I already have as well. So when you answer these 2 questions, never say I don't know, or for any question in the future. You may want to go back and look at your notes. In this case, we don't have any notes. This is an introductory type of question, and I often make them sometimes more challenging just so that you are on your toes and you're thinking. So what do you think is causing this type of phenomenon to occur? You see this picture over here on the left, which you may have seen. It looks like something's sort of levitating in here. It looks like the globe is sort of floating in midair. I'm going to start this video here, and I want you to watch what they have. Of course, it's pretty much the same device over there on the left, but I want you to watch what's going on. So the phenomenon is an event. Phenomenons, you're going to hear that sometimes be used. So when you hear the word phenomenon, it just means like what is happening, what is causing this event, this occurrence to take place. So you see that globe, which is, like I said, that's sort of that same one that's over there. He's showing you just sort of what's going on. He's showing you the very bottom of each one of those. And basically it looks like you've got a magnetic attraction. But once they take this bar away, you can see that it doesn't, sort of go up onto that particular device. You also know that it looks like it's plugged up, okay? So the question here is, what do you think is causing this type of phenomenon or event to occur? And number 2, will the motion continue on forever? Why or why not? So when you answer number 2 in a yes or a no, don't tell me an I don't know, but tell me a yes or a no. Give me a decisive stick with your guns type thing, and then explain to me why you think so or why you don't think so. Okay, because that's going to be what your 2 questions are on the next when it pauses for Edpuzzle. I'm not going to give you the answers to those questions. That is sort of going to come along as we go along. I know that's not always what you want to hear. You always want the answer right then and there, but we're not going to do that. We're going to try to learn why that phenomenon is taking place. So here is your standard PS2.1. We're going to look at parts of this, but while you may not be designing so much, you will be conducting investigations online to try to figure out how are magnetism and electricity related, because they are, and that is an extremely important idea. There's a lot of these terms that you should have already seen in your first Quizlet assignment with flashcards: electromagnets, generators, electrical motors, and basically what an electrical current is, which you talked about in 6th grade, and how to increase or decrease the magnetic field of these. So that's something that we're going to be looking at. You'll see some other things on here: cross-cutting concepts, science and engineering practices. Those are other standards within our science unit that I'm not going to worry about today to talk about, but maybe when we get back into the classroom, I'll talk more about that. So, like I said, this is where your notes will officially start. So you can see that there's a bunch of blanks on my page, just like there's sort of blanks on your page of your notes. And what you're going to do is, as I uncover these things, you are going to write them down and fill them in. You will probably have to pause the video. I'm not going to pause my talking to wait for you to write like I would in the classroom. So always pause the video as long as you need to fill it out, okay? So what is a magnet? First and foremost, a magnet, as you can see here, is attracting some materials down here. So a magnet is an object that will only attract iron. Iron and other types of metals, such as cobalt, nickel, and neodymium. Like I said, iron, nickel, cobalt, and neodymium. Neodymium is a very, very precious metal on the periodic table, but it is also very expensive. So we don't usually use neodymium because they are expensive. Iron, nickel, and cobalt combinations is what we typically use if we were in the classroom and if you have a magnet at home. When we look at magnets, they all have three properties, and so you can sort of see this particular magnet is being broken into two. Okay, that's what this illustration is trying to show you. So each one of these little swirly whirly things is basically like a compass saying this is the north end of it and this is the south end of it. And you notice that it is aligned with the north end of the North Pole and the south end of the South Pole. So they're all in the same direction. That's really important. You can think about those as like little individual atoms within a magnet, because that's really what it is. Are little individual atoms that all have these charges. And you guys talked about atoms last year, and different parts of the atom have different charges. So the very first thing I want you to write down where you see number 1 is that they always have a North Pole and they always have a South Pole. That's the very first thing I want you to write down for number 1. Now, when you look at this particular magnet, when it breaks apart, you see that the magnet is sort of duplicated. That now we've got a magnet on the left side, then we've got a magnet on the right side. And that's exactly what happens. You can't break a magnet apart without having a north and a south pole end. This illustration right here is trying to sort of show you that no matter how many times you break a magnet into two, and this little orange dotted dash line illustrates that, you break it into more parts. So if I were to take this big one and split it in two, I would now have a magnet with a north and south end, a magnet with a north and south end. If I take the smaller two now, I can make 4 out of them. It doesn't matter. As long as I continue to have a magnetic material and I continue to split it in half, it will always have a north and a south pole. Always. The next thing that magnets always have is, if you look at this particular picture, is a force. And if you look at these, this is something we'll talk more about later, are forces. And a force is simply a push or a pull. So depending on which end of your magnet you have towards one another, you are going to see that they are going to be attracted or be repelled. And repelled is just another way to say pushed away from one another. So for number 2, I want you to write down they have a magnetic force. And in parentheses, write a push or a pull. So that's what you're writing down for number 2. Then on what you should see on your notes there is that you have a bullet point, and your bullet point should be filled in with that opposite poles are going to attract. So what we're going to do here is basically these are the 2 pictures that you have. You are going to write on these pictures. So when we write on these pictures, we're going to designate each one of them with a north and a south pole. And this is the picture that I would be showing you in the classroom as to how it should look at the end. So I want you to designate. You could designate the red end as the South Pole, the white end as the North Pole. And when you do that, you're going to draw these little blue lines, and they don't have to be blue, but you're going to draw those little lines in there. So technically what you should end up with is something like this. You would have this, let me decrease my size just a little bit. You would have that this is the, that didn't decrease. Okay, that this is the North Pole. And this is the South Pole, and like I said, it doesn't have to be in color. So on each one of these, you would want to write an N or an S, and this would be an N for the white, and this would be the S for the South Pole. And then you would also want to show the individual attraction. So these lines here are what you would draw to show that attraction. Okay, so there you go. It looks pretty much like this one. Yours is probably going to be a little bit neater. I was using a highlighter there and didn't mean to. So this is what it should look like. if it doesn't look like this on your paper, you will not get credit, okay? Hopefully it's not as sloppy as mine looks, but please make sure it looks that way. Now, the second part of this having a magnetic force is, of course, that they are going to be pushed away or repelled. So in this animation, you can see that the two ends are repelling, and then it shows you the two S's repelling. So I've got two sets of pictures here. So when you see this picture and it says pushing, one set needs to look just like this. So once again, this is what needs to be on your notes. Okay, how it needs to be illustrated on those little diagrams that you see. And then also you're going to see these right here, okay, on the other side, and this is how it should look for the other, because you have two different ways that this could actually be occurring. So please make sure that when you are doing this, that you are actually writing and drawing and illustrating, because I am looking for that as completion in your notes. Now, the third property that everything has is a magnetic field, and this is an extremely important part of it that is going to, well, all of these are important properties, because when we talk about an electromagnet, that is also going to be a thing to take place. All these properties are going to apply to anything that we look at from here on out for the most part. So when we look at this, it says it has a magnetic field, so you need to fill in the blank because it's not completely filled in on your note paper. Okay, so a magnetic field, the definition for it, here it goes. You're going to write this down right after that colon, is an invisible force. You can't see it. If you watch the Brain Pop video like you were supposed to, that was one of your questions on there. It's not something you can see, but we as scientists will mark them on paper by using what we call a field line. And so that's what these arrows over here are basically indicating are your field lines. That's what our picture is sort of going to look like when we're said and done. And that little compass going around is basically showing how it is starting out of the northern end of the magnet and going into the southern end of the magnet. So what we want to do then is we want to take, basically you should already have the north and the south on your paper, just like you see here. So the north and the south is already drawn there for you. And then what we're going to do is draw the field lines, just like you see over there in that picture. So what we want to do is take this, and remember, we want to go from the north to the south. So I know this picture is illustrated that way, but I'm just going to show you so that you don't always think it's going from left to right. It doesn't matter left to right, it's from north to south. So we want to take a line and show that a magnetic field, which is basically just saying that if I hold an object away from a magnet, it gets attracted. That's the field, okay? That's what we mean by field. So the football field is a place where you play. A magnetic field is the place where an object would be attracted or repelled away from another one. So these lines just indicate the direction of flow around, and I know I've got a lot more arrows over there, but once again I'm going to take another line. This is a magnetic field line out of the north and into the south. Okay, so draw those arrows to indicate that flow, because what this is a flow of electrons. It's a flow of that energy through those through the magnet. Now this is because I only drew one on each side, this is a very, very weak magnet. If I were to draw more lines like so, if I have one, I'm going to have two. Okay, so if I draw one on one side, I have to draw one on the other side. But if I draw two on one side, I have to draw two on the other side. So, as you can see, why I'm showing you a nice pretty picture over here on the right is because mine is very sloppy with me trying to write on my screen. So, if you look at this picture over here, you can see that some of these lines look like they don't connect. Well, it's just because the picture doesn't connect, okay? These would actually connect in the real world, just like I'm sort of showing you. So, please don't just end your line haphazardly. They really need to connect. Okay, and then this one would go all the way over here type thing. So as many as you are going to draw is going to be what you have on each side, and they should be connecting. Now, The very last thing on this particular portion of it that they have 3 properties is that there's 2 bullet points that you need to fill in as well. The more field lines you have means that you're going to have more force and that there's going to be a stronger attraction, meaning that your magnet can pick up more things. The less field lines you have would represent an object that has less magnetic force and therefore attract less objects and not have the strong magnetic field that everything else would have.